7.14, free energy of dissolution. All right, this section is not going to be long because we'll go more detailed in a future unit. So this is intro stuff, all right? And so let's get over it. All right. So we're going to talk about enthalpy. We're going to intro some other concepts that we've briefly, vaguely mentioned in previous units. So just quick recap on enthalpy. Enthalpy is related to thermo. And so as a reminder, your delta H is based off the potential energy of your products and your reactants. So here's my delta H here on the reaction progress curve. So products minus reactants, and this is potential energy on this axis, right? And so if delta H is negative, it's exothermic. If delta H is positive, then it's endothermic. All right. So entropy. We briefly mentioned entropy when I'm talking about, what was I talking about? States. Yeah, states. And so entropy is designated by S. Don't ask me why, I don't remember. And so entropy is talking about how disordered something can be. And the way I personally remember it is by blocks. And I think about, in my head, how much energy is needed to make this happen. So this is how I think about it. And so delta S, if it's negative, it's more orderly. And the way that I personally remember this is, anytime I need to organize something to make it more orderly, I need to use up energy. So using up energy is negative. So that's how I remember. And then delta S, if it's positive, it's less orderly. It's more chaos. So you can see here's my two examples with some blocks. And so these blocks here are organized in a nice way. Maybe we're making like a little village or something. And so since it's more orderly, overall this delta S is negative. Versus here, I just threw the blocks in some bucket or whatever. And so since it's less orderly, it is positive S. All right. Okay. Gibbs free energy. So again, we're also going to talk about this in Unit 9 more, but quick intro here. And so Gibbs free energy is delta G, and it's the free energy change, okay? I'm not going to go into this more other than that because, again, you'll learn more about it later. And so my for now definition is going to be based off the energy available for this reaction to even occur, okay? And so delta G is talking about spontaneity. And so spontaneity meaning it will naturally happen or not. And so if I have a negative delta G, that means it's spontaneous. It's gonna happen naturally. So I do not need to put energy in order for this reaction to occur. If I have a positive delta G, it's non-spontaneous, so I need to input energy in order to do that. So, an example with batteries. So, if an appliance is using a battery, right, then that means the appliance needed the energy from the battery in order for the reaction of the appliance to actually work. Inside the battery itself, like the way that batteries work, is you have a reaction happening in it. Because essentially you're trying to exchange the electrons in order to have an electricity input. And so that reaction itself is spontaneous. It's just going to occur. And so if you have a bunch of batteries, you know how sometimes they label the expiry date on those batteries? The reason why is because those reactions are happening spontaneously, even if it's not being used as an electricity source for something. And so when you have a set of batteries and you keep them in like a box or something, then you want to make sure you test them to see if any more of the reactions inside the battery is even working or not. Because technically it's just a reaction in there. And so that reaction again is spontaneous. it's going to happen. And then we try to utilize that energy from the reaction in order for us to use an appliance. In this case, a remote control or something for this picture. Cool. Okay. So, dissolution. Delta G is related to the different factors we talked about. So when we're talking about dissolution, we're talking about dissolving something. So the first thing we need to think about are IMFs. So we need to think about the solute IMFs to itself, so the various solute particles to the other solute particles. And then I need to think about the IMFs of the solvent to itself as well as other solvent particles. So then the solvent, how is it going to be organized in 3D around whatever is being dissolved? So the solute, whatever that solute is. And so then what kind of interaction is there between that solvent and that solute that is dissolved? And so is it IMFs? Like what are they essentially? So what does these three things mean, right? So honestly, it's easier to go through an example. We're going to go through these steps. We're going to talk about enthalpy and entropy, and then we'll talk about the why. Again, the why is the most important part. Like knowing delta H and delta S, sure. I mean, that's not, too hard to think about, but we do need to think about why, because we're always about the why in this class, right? So let's think about the various steps in order to dissolve this sodium chloride salt in water. Okay, so let's think of that. What's happening in the first step? So the first step is the solute. So in this case, it's the salt over here. And so those are going to separate. So as a reminder, the ions are super attracted to each other, right? Because we have a positive and a negative. Good old Coulomb's law. And so this great force of attraction needs energy to separate these ionic bonds, because remember, the sodium and the chloride are part of an ionic bond, and so we are going to separate those bonds. When we separate those bonds, we're going to talk about the delta H and delta S in a second. Okay, second step. The solvent is going to separate, so the H2O needs to separate. As a reminder, H2O interacting with other H2O molecules are hydrogen bonded together. As a reminder, hydrogen bonds are not bonds. They are an IMF. And so we need to input energy to separate those IMFs, okay? And so then we have step 3, which is the solute and the solvent forming an attraction. So here you can see in the picture I'm showing right here, I have the polar negative side of the water and the positive ion interacting. So we have an ion dipole interaction, an IMF there. Okay, so let's talk about enthalpy and entropy for these steps. So for enthalpy, it's going to be positive delta H because you needed to input energy, so aka endothermic, in order to break the ionic bonds. Now, because we are breaking these bonds, it is getting more disordered. It is not as organized as it used to be, because remember, these are organized. And so when I input energy to break the bonds, now it's like going to be dissolved all, it's separating all willy-nilly wherever it's separating to. So that's why it's a positive delta S. Okay? So for step 2, my separating of molecules, so in this case it's water, we're separating the IMF known as hydrogen bonding, and so that also needs energy to separate that IMF. And so again, IMFs, especially hydrogen bonds, have a beautiful arrangement, and so when you break that, it's getting more disordered. Okay, so then step 3, as I mentioned earlier, we have an ion dipole interaction, that IMF. So we have an attraction, okay? And similar to bonding, because as a reminder, when you form a bond, you release energy. So it's exothermic. An attraction forms is also releasing energy. And so since we're releasing energy, that's going to be a negative delta H, because that's an exothermic process. Okay. And so if we look again at the picture, we have the sodium here and the partial negatives of the water pointing towards that positive. And then for the chlorine ion, have the opposite, where the water partial positives are interacting with the negative charge of that chloride. And so because of this, it is being arranged in a specific way. It is being more organized because of that water's dipole to the attraction of those ion charges, and so therefore I have a negative delta S. Cool. Now, will different salts actually dissolve? We know sodium chloride dissolves. That's just straight up table salt, and we've dissolved that a million times. And so if we're looking at other kinds of salt rather than sodium chloride, then will those dissolve? And so that's going to depend on delta G, which is going to be unit 9. Yeah. And so this section, honestly, all you need to know is the relation between solubility of the salt and the changes in delta H and delta S to see the dissolution process that we just went over here. Again, you should be able to explain this process and what's happening to delta H and delta S. And then, like I said, we're going to do this in Unit 9 where we learn how to use these values and see if a process is actually going to happen. Okay, quickie section. All right, bye.